Hi, this is a video lecture series of algorithms and this is your instructor Munira Topia. In today's video, we are going to see definition of algorithm, characteristics of algorithm, design and analyzing steps of algorithm and issues in writing algorithm. So let us start by defining algorithm. There is no universally agreed upon wordings to describe this particular notion. There is a general agreement about what the concept means. So here algorithm concept means it is a sequence of unambiguous instructions for solving a problem. That is, for obtaining required output for legitimate input in a finite amount of time. A problem which is need to be solved by a computer. A computer is nothing but electronic device, or it can be a human being or any person capable of getting computing. So here in this particular subject, we are actually focusing computer algorithms. That's why we are considering computer as a electronic computer system. Our problem which is need to be solved by a computer who needs input so it can produce some output requires an algorithm. So algorithm basically takes an input as a problem and finds out the sequence of steps in order to solve a particular problem. Let us start discussing characteristics or properties of algorithm. Algorithm has 5 important properties. Let us start discussing them in brief. The first property of algorithm is non-ambiguity. Ambiguity means confusion or conflict. As you can see here, the signboard says it is only one way, but an arrow that is shown on a signboard displays it as two ways. So there is an ambiguity, whether it is one way as it is written or it is two way that is being described or it is being picturized. Our algorithm should be conflict free. It should be clear. Instructions should be precise. Instructions should not conflict with each other. So that is the first property of algorithm. Second property is range of input. Consider I have a multiply algorithm which takes 10 and 20 and produces output 200. But same algorithm must take any two integers and produce a result. If my algorithm works for only one instance of input, it cannot be called as algorithm. So algorithm works for range of input. There is a finite set of input for which algorithm produces correct output. So here I can have a multiply algorithm which works for two integers, or I can have multiply algorithm which works for two real numbers, or I can have three integers multiply algorithm and so on. So any algorithm does not only work for a single instance of input. It should take different instances of input and produces result accordingly. The next property of algorithm is multiplicity. Take an example. If I want to find number is even or odd and I want to write down its algorithm. So let me represent it in a first way. First, I will read a number. Second step, I will take number modulo 2. That is nothing but finding remainder. Now, finding remainder, if remainder is 0, I conclude that number is even. But if remainder is non-zero, I conclude that number is odd. So these are the series of steps to calculate or to find out whether the given number is even or odd. This is the one way of representation, that is nothing but flow chart. Multiplicity says that we can represent same algorithm in other different way. Another way of representing same algorithm is in a simple pseudocode. Read A. If A mod 2 is equals to 0, then A is even, else A is odd. Now, this piece of algorithm might look like a program that belongs to a particular language. But actually, this piece of code or piece of instruction or a piece of algorithm is not actually belonging to any programming language. It resembles like instruction set and instruction written for computer program, but they are actually algorithms pseudocode. Another way of representing same algorithm is in simple English like language, like read a number. If number modulo 2 is 0, then conclude that number is even, otherwise say number is odd. So again, this is the third representation of same algorithm. First one we have seen as flowchart, second was pseudocode, and third is simple English like language. So multiplicity says that for any problem to be solved by an algorithm, that algorithm can be specified in multiple ways. There is another meaning of multiplicity. It says that to solve a particular problem, there do exist multiple algorithms which uses different approaches to solve same problem. Now, here our problem is same, that is number is even or odd. But here approach or the steps we have written for an algorithm is different. So first step says that read a number, check the last digit of number. If that last digit is among 0 to 468, then conclude that number is even. Otherwise, we say that number is odd. So this is also a method of finding that number is even or odd. One algorithm can be represented in multiple ways, or to solve a single problem, there do exist multiple algorithms. So that is the property of algorithm. So the same algorithm is represented in several ways and there are several algorithms to solve a particular problem. Next property is finiteness. Finiteness says that your algorithm should terminate. Your algorithm can terminate after several seconds, after several minutes, hours, days, years, even after centuries. But there should not be any algorithm that runs infinitely. So finiteness is one of the important property of algorithm. Moving towards next property, that is speed. If there are algorithms for solving the same problem, there are different algorithms and each algorithm is based on different idea or different strategy, then we say they solve a problem in different speed. For example, to solve a problem, if I have two different algorithms, one is taking 5 steps and another one is taking 10 steps, then both of these algorithms are correct, but the speed of these are different. So it is completely based on the strategy or an idea that you have chosen to design your algorithm. So here we have to conclude that there are 5 important properties that any algorithm should have, that are non-ambiguity, range of inputs, multiplicity, finiteness, and speed of algorithm. Now we will see what are the steps required to design any particular algorithm and how to perform analysis of algorithm. So first step in design or analysis is to understand a problem for which we are going to design or to analyze an algorithm. So understanding of problem is very first step. Unless and until you don't understand what the problem is, what you want to get, what you want as an output, what will be your input, all these things will not be clear. Till then you will not be able to write down an algorithm. So very first step that you should be clear about is the understanding of problem. Here at this step you should also know what will be your input and what will be your output. The next step, that is decision making. You have to decide what will be your computational device. Computational device like parallel system or a serial system, are there any distributed computing, and so on. The next decision you should make is on exact versus approximation method, that whether you want output of algorithm as an exact value or an approximate value. Now you would think that who wants an approximate answer? But there are some problems whose exact solution will be time consuming or which is not required. Take an example of finding square root of a number. Now, square root of a number, if we are going to get an exact value, it might end up into n decimals. But in our, as per the expectation of an application, we can get an approximate value of that square root function up to say 2, 3 or 5 decimals. That are our requirement or what as the problem is. It depends on that. So next decision you want that do you want an exact solution or an approximate solution of a given problem. The third decision that you should make on data structure. Which data structure you are going to use in your algorithm. For that purpose, you know the basic data structures. There are, if you know, two types of data structures, linear and non-linear. Inside linear, there are arrays, list, queue, stack, whereas in non-linear data structure, there is a tree and graph. There is other data structures too, and which are variations of tree and graph. So you should know the proper working of data structure if you are going to select them in your algorithm. The last decision you should make clear about algorithmic strategy. There do exist different algorithmic strategies like divide and conquer, dynamic programming, greedy programming, backtracking, branch and bound. So all these strategies you should know and you should select the correct strategy as per the requirement of problem. So after making all these decisions, you proceed to the next step, that is design of an algorithm. So designing of an algorithm is a not automated task. It is of course a logical task which is based on one's logical thinking capability. But obviously we can improve this capability by learning different algorithmic strategy, by learning existing algorithms. So we can write algorithms better than that. After designing an algorithm, we have to find out its correctness, whether algorithm works correctly for input and output. For correct input, it is producing correct output, and for incorrect input, also it gives incorrect output. That is also important. If algorithm is correct, then we take our next step, that is analyzing. But not always it is that once you write an algorithm and it is always correct. So it might happen that my algorithm doesn't do a work correctly. So we can go back to decision making step or on design step and we can make some changes, come back and check its correctness. Once algorithm is proved correct, we will do analysis. In analysis step, basically what we are computing time and space complexity. What is the time taken by algorithm and what is space taken by algorithm. So as per the requirement of problem, if my time and space is not up to the mark, then we can again go back to our decision making step or a design step and we can make some changes, design an algorithm, we can make some changes in design, we can again check the correctness and come to the analysis. Unless and until efficiency, that is time and space complexity, doesn't comes as per our expectation that is given in our problem, original problem, we will not go to our next step. The next NF is coding the algorithm. Once algorithm is ready, its correctness is proved and its complexity have been analyzed, we just have to select a particular language and code that algorithm accordingly. So these are the steps that we have to follow it down in order to design or perform analysis of any algorithm. Now, as it shows, it is very simple steps that we have seen. But are they those simple? Are there any difficulties in writing algorithm? So yes, there are two difficulties, two issues writing an algorithm. First one is how to design an algorithm. So as I said, algorithm designing is a logical process for and that can be improved by learning different design strategies and also study existing algorithms. This can help you to improve your designing capability of algorithm. Another aspect of algorithm is to perform analysis. While we are performing analysis, we are actually measuring input time, we are measuring input size, we are measuring running time, measuring space required by algorithm, and last is order of growth. That is nothing but how changing input size would result in running time of algorithm. If I give one input, algorithm takes only 1 second. But if I get two input, Algorithm takes 10 seconds. So what is the relation between number of inputs and running time of algorithm? That is what an order of growth is. We will cover this particular topic in our next lecture. At the end of this particular lecture, you should be able to answer that what is the definition of algorithm, what are the 5 important characteristics of algorithm, what are the steps of designing and analysis of algorithm, and what are 2 important issues in writing algorithm. Till then, this is Munira Topia signing out. Thank you for watching your video.